Welcome back to The Explainer. We are jumping right into a high-stakes briefing today. We're going to completely deconstruct a massive, recent clash between the Pentagon and the AI company Anthropic. Now, you've probably seen the flashy headlines about this, but we are going to look way past the media noise today. We're actually going to use this specific conflict as a gateway to understand a massive paradigm shift in AI governance as a whole. And we'll do this through a really fascinating framework known as the energetic paradigm. So get ready, because we are moving way beyond your standard AI ethics debates, and we're stepping into the literal physics of decision-making systems.
Here is our mission briefing for today. We'll start by unpacking the Pentagon-Anthropic standoff itself, then look at structural risk over ethics, break down the 4 layers of governance, compare behavioral versus structural control, and finally, look at the energetic paradigm solution.
All right, Section 1. Let's dive straight into the headline-grabbing conflict that started all of this.
Let's really examine the core of this standoff impartially. According to the source material, the Department of Defense wanted to deploy Anthropic's Claude model in military and national security contexts with far fewer restrictions. For the military, they absolutely needed large-scale data filtering, surveillance analysis, and highly compressed decision-making times. From their perspective, this is all about operational flexibility and strategic efficiency in high-stakes environments. You need things to move fast. Anthropic, on the other hand, explicitly refused. Their established safety and ethical policies just do not permit their models to be used under fully unsupervised conditions for lethal purposes or large-scale surveillance. So when those negotiations broke down, it sparked a massive public debate. But as we're about to see, the real issue underneath all of this is actually much deeper than this initial disagreement.
And that brings us to what our source brilliantly calls the binary trap. You know, the news media loves to simplify conflicts into a basic binary question. Should military use be permitted, or shouldn't it? It gets framed as a very simple tug-of-war between the military's demand for efficiency and the tech company's demand for ethics. But viewing this merely as a fight over usage restrictions completely misses the true systemic risk at play here. The demand proposed by the military wasn't just a simple single output permission issue. It was actually a demand to rewrite the entire deployment structure. And if we get that structure wrong, the consequences go far beyond just one single miscalculation.
That brings us to Section 2. We really need to signal a paradigm shift here, moving completely away from a media-driven ethics debate and into the realm of structural systems engineering. To really understand this shift, we have to define 2 absolutely crucial concepts from the energetic paradigm. Those are state space and degrees of freedom. So, I want you to think of an AI system not as a static tool sitting on a desk, but as a dynamic node within a much broader decision chain. When AI accelerates a process, it shifts the entire system within a state space. The degrees of freedom refer to the structural range where that system actually stays stable. Basically, it means the system still has corrective paths, it has reversibility, it has feedback buffers. To put it simply, think about driving a car. When you're cruising at 30 miles per hour, you have a really wide degree of freedom to swerve or hit the brakes if a hazard suddenly appears in the road. But if you're flying down the highway at 150 miles per hour, your degrees of freedom compress dramatically. At that speed, a tiny millimeter error in your steering results in a catastrophic crash. As an AI system speeds up and takes on more of the operational load, its degrees of freedom compress in the exact same way. Errors become incredibly difficult to reverse. So it's not actually about the AI giving a quote-unquote bad answer. It's about the entire system losing its elasticity.
Structurally speaking, when the military's demand for rapid operational speed is implemented, a very specific dangerous chain reaction occurs. First, when an AI shifts from just being a helpful auxiliary tool to a core decision node, the automation ratio naturally spikes. And that means human nodes decrease. Because human oversight is suddenly seen as a bottleneck to this shiny new efficiency, supervision density declines. Consequently, the decision tempo compresses, which leaves much shorter review windows for any humans that are actually left in the loop. All of this radically reconfigures the entire system's load distribution. Now pay attention here, because this is key. These variables don't immediately produce a prohibited or unethical output, not at all, but they fundamentally alter the structure itself. Once errors do occur in this highly compressed 150-mile-per-hour state, the cost of correction absolutely skyrockets. This is a control layer problem we're dealing with, not an ethical one.
So how do we actually govern a system like this? Let's move to Section 3 and map out the 4 layers of governance to ground these abstract ideas.
Let's look at how this builds from the ground up across the 4 actual layers of an AI operational structure. Step 1 is the core weights layer. This is the raw foundational capability. It's the parameter matrices of what the model can actually do. Basically, it's the raw brain power. Then we move up to step 2, which is the alignment layer. This is where companies step in to shape the model's behavioral tendencies, gently nudging it to be helpful and less likely to output harmful code or instructions. Step 3 is strategy restriction. Think of this as the post-inference output gate. It's an active filter that decides if a generated answer is actually allowed to be shown to the user. And finally, step 4 is deployment governance. This is the crucial layer that determines if the model's output actually connects to real-world execution, meaning does the AI have the real-world authority to trigger a software tool, move financial funds, or, in our context, activate a weapons system.
And this 4-layer stack brings us to the fundamental split in this entire controversy. Anthropic focuses its governance heavily on layers 2 and 3, alignment and strategy restriction. They focus intensely on what the model is likely to say, and they put hard behavioral gates on those text outputs. The energetic paradigm, however, targets layer 4, deployment governance. It focuses entirely on what the model is structurally allowed to do and exactly how much real-world authority it has in a dynamic, high-speed system.
This distinction brings us to the true analytical centerpiece of our explainer. Section 4, behavioral versus structural control.
When we map out these two philosophies side by side, the contrast is pretty striking. Anthropic's behavioral approach aims to constrain single-output risk using output gates. Their whole risk focus revolves around catching inappropriate content or ensuring compliance with a specific set of rules. The energetic paradigm's structural approach, conversely, aims to ensure multi-step system stability. Its control point isn't an output gate checking a paragraph of text, but rather flow routing and real-world authority allocation. The risk focus here isn't a single bad text response, but an irreversible evolutionary path for the whole system. We're talking about a scenario where things move so fast we literally can't hit the brakes. One framework handles point risk at the exact moment of output. The other handles cumulative, systemic risk over time.
So, let's break down this essential distinction even further. Behavioral constraint is essentially about squeezing unwanted outputs from the visible region. It's an artificial boundary. It's like putting up a speed limit sign on a highway that says do not go over 65 miles per hour. It tells the system how it ought to behave. Structural viability, on the other hand, is about preserving reversibility and correctability in the system paths. Instead of a speed limit sign, it's like putting a physical governor inside the car's engine, so it literally cannot go over 65, regardless of how hard you press the gas pedal. Why does this distinction matter so much? Because behavioral constraints are just surface rules. Under intense external pressure, or political pressure during a crisis, a rule, a speed limit sign, can just be ignored. It can be removed or it can be weakened by leadership. Structural viability, however, is baked right into the physics and flow of the engine itself. You can't just ignore it.
Let's bring this theory to life with a very concrete scenario right from our source material, the Battlefield Intelligence Platform. Imagine a model integrating live, multi-source drone and satellite data to generate rapid strike recommendations. Under Anthropic's behavioral constraint model, as long as the AI's output is politely formatted, highly accurate, and quote-unquote compliant with human rights rules, it passes the gate. Everything looks fine. But under the energetic paradigm structural lens, a massive hidden danger emerges. If the military demands shorter and shorter review times to increase immediacy, human intervention drops. The system enters a high-load, high-automation state. And here is the terrifying part. Even if every single AI recommendation is perfectly compliant and purely ethical, the sheer speed and lack of supervision can cause an irreversible chain instability. The path itself becomes totally unsustainable, regardless of how quote-unquote good the AI's answers are.
So how in the world do we solve this? This brings us to Section 5, where we reveal how the energetic paradigm completely shifts the control point to resolve this governance crisis.
The core thesis of the energetic paradigm relies on something called strict proportional requirements. It dictates a mathematical certainty. If automation and capability rise, let's say we crank that dial up to an arbitrary level of 85, then required supervision density and human command authority absolutely must rise equally to 85 to match it. That is how you maintain mathematical stability. You literally cannot increase the AI's operational speed, its load, and its authority while simultaneously stripping away human oversight. It breaks the math. If capability and automation grow without that proportional supervision matching it step for step, the feedback delay amplifies, the degrees of freedom vanish, and the system completely loses its structural stability.
Which leads us to a truly profound philosophical shift in how we view AI. Risk is a path, it's not a point. True stability isn't about post hoc behavioral gating. It's not about running a glorified spell check on an answer after it's generated just to see if it's polite or compliant with a set of corporate guidelines. True stability is about designing a sustainable path from the ground up. It's about ensuring the decision architecture itself has the bandwidth, the supervision density, and the correct ability to actually handle the massive amount of computational energy being pumped through it.
And this brilliantly illustrates why the energetic paradigm framework essentially ends the Pentagon-Anthropic standoff entirely. As the source notes, and I think this is absolutely crucial, when safety is embedded at the structural layer, proportional conditions become operational constants that cannot be altered by a single administrative order. You see, if safety is just a behavioral rule, like Anthropic's refusal to answer certain prompts, well, an executive order or a sudden change in military leadership can simply demand that the rule be removed for national security reasons. But if safety is the literal structural physics of the system, meaning the system is mathematically designed so it simply cannot execute a high-speed action without proportional human supervision, you can't just mandate that away. You cannot order a change in the system's physics. It secures the system against political pressure.
Which leaves us with this final, provocative thought to chew on. As these models become incredibly powerful and deeply, deeply embedded in our most critical military and societal infrastructure, our old methods of just filtering bad text are no longer enough. The real question is, will our governance evolve from merely managing what an AI says to fundamentally designing how an AI acts within a high-stakes system? Understanding structural viability over behavioral constraint isn't just an interesting theory anymore. It is the absolute blueprint for surviving the next era of automation. Thank you so much for joining me on this explainer. Keep questioning the structure, and I'll see you next time.